Hello guys, once again welcome on board to my YouTube channel, and today we'll discuss about the ATA chapter 21 pressurization system of Airbus 320 family, and this is very interesting topic. Don't forget to miss any point, watch this video till end. In previous video we already covered idea about the air conditioning system, how the aircraft is stay cool. Then part 2 we covered about the complete in detail knowledge about the air conditioning system. Then part 3 also we have covered about the avionics ventilation system in deep knowledge. And now let's go for the part 4 pressurization system. And please don't forget to like and subscribe my YouTube channel for getting more video on another ATA chapters, and lot of small reels also I am putting for basic knowledge, general knowledge and transit issues, and that is very useful for you guys. Take your time, don't watch at a time every video, just watch one video. If you're watching one time also in a day, then you will be have lot of knowledge. So guys, don't forget to like, share, subscribe my channel, and let's start with pressurization system part 4. Why this is important, what are the components are there, what are the function of the components. We'll discuss all the things one by one, slowly. So sit back, relax, enjoy this video till end. So let's start with pressurization control system. Pressurization system in Airbus 320 family normally operates automatically to adjust the cabin altitude and rate of climb to ensure that maximum passenger comfort and safety. So here is a 2 points: maximum passenger comfort and safety. That's why pressurization system is required. And there is a lot of place in the aircraft which is coming under pressurized area. So we should talk about the pressurized area, what are the component, what are the location is there for pressurization. So first pressurization area is cockpit, because captains are there, lot of flight crew are there. Then second area is your all the cabin is pressurized, and there is avionics, lot of avionics bay, that is also pressurized. Then cargo area, forward, aft, this is also pressurized area. And if you talk about the pressurized area, last video I have told you about all the pressurized door. Whatever compartment is pressurized, door is made of maximum aluminum alloy, like passenger door, cargo door, bulk cargo door, avionics ventilation door. Whatever unpressurized area is there, that door is made of carbon fiber material, just for example composite material. So unpressurized area all made of unpressurized area all made of composite material, like pack belly fairings, all are composite material. If we'll talk about the APU compartment, that is also composite. If we'll talk about the APU compartment, that is the hottest section for the tail. So that door is made of titanium alloy, not composite, but that is also one pressurized area. Then CVR compartment or THS compartment, you'll get it here. That door is also made of composite, that is also unpressurized area. So if you think what are the unpressurized area, so I'll just tell all the wheel well area is unpressurized area. This is also interview question. And belly fairings, all the belly fairings almost unpressurized area. Then APU tail section is unpressurized area, THS section is unpressurized area. So this many area is unpressurized, and rest all area is pressurized area. This is the concept behind the pressurization system. So concept of the system is very simple. Air is supplied from the air conditioning pack to pressurize the area. So there is no separate air unit. We are using air conditioning air. So concept is very simple. Air is supplied from the air conditioning pack unit and to the pressurized area. And there is an outflow valve used to regulate the amount of air allowed to escape from the pressurized area. This is your outflow valve. This is your outflow valve, and from there air will allow to escape from the pressurized area whenever required, or automatic control depend on the scenario. So automatic control valve is provided by two CPC computer. There is a two CPC computer, cabin pressure controller 1, cabin pressure controller 2. In this CPC 1 is no go. Already I have uploaded video on YouTube why this CPC 1 is no go, because there is a feedback sensor which will give indication on the ECAM about this valve open or close condition. That's why this is no go. Please watch my video for no go computers. All the no go computer videos available on my channel. So there is a 2 CP, each CPC controlled 1 electric motor on the outflow valve assembly. There is a 3 motor on the outflow valve assembly. We will discuss in the next slide. three motor, one for CPC1, one for CPC2, another is RPCU, residual pressure control unit. CPC interface with another computer to optimize the pressurization, depressurization schedules. So you can see there is a FMGC, AIRBUS, and this is all taking data input from the different computer. Slowly we'll go till in all in detail about the AIRBUS, FMGC, whatever function is there. Then you will get a complete idea about the pressurization system. So there is a two automatic pressurization system. Each CPC has its electric motor make of one system. Only one system operate at a time, with the other system acting as a backup in case of failure. So if you open the ECOM page, pressurization system, you will find out it is written on the system 1 and system 2. So system 1 means CPC1 is controlling, system 2 means CPC2 is controlling. So that's why it is written system 1 and system 2. One will work at a time, other will act as a backup system. In case of failure of one system, it will automatically switch to the another system. System is command will alternate each flight. So every flight that CPC will change over from one CPC1 to CPC2. Third motor is installed. Third motor is installed for the manual operation of outflow valve. This valve. So there is a three motor on the outflow valve. In case of both automatic system fail, again there is a redundancy system in Airbus 320 family. In case of failure of both automatic system, then what will happen? To protect the fuselage against excessive cabin differential pressure, there is a safety valve are installed on the rear pressure bulkhead. This is your location of safety valve. Once you are going to the DFDR, CFDR compartment or THS compartment, there is a rear pressure bulkhead. You will find out there is a two scoop, that is your safety valve, two safety valve. So safety valve also protect against the negative differential pressure, and there is a RPCU, I told you, residual pressure control unit, control the residual pressure in the cabin and takes over the control of outflow valve automatically by providing power directly to the manual motor of the outflow valve. So this will give direct supply to the manual motor of the outflow valve to control the cabin pressure. Basically, residual name after landing, this computer will come in the picture, and this will open the outflow valve completely to dump all the pressure from the cabin area. And you will get on the doors, passenger door, you will get red light indication, also blinking light. Already that video also available on my YouTube channel, why that blinking light is there. In case of arrival aircraft, there is a blinking of red light, means still cabin is pressurized, there is a residual pressure. What is the trick how you can come across that whenever you are attending arrival aircraft with that condition? Please go through my video. If you want, I will share the link for that. Please text me personally, so I will share you. Wherever you will get a pressurization related indication. So if you look door, if you see the door page, you will find out the vertical speed on the door page, and in cruise time you will find out this vertical cabin vertical speed on cruise page. Cabin altitude depend on the phase of flight, and already phase of flight already I have uploaded video what are the phases of the flight available, and cruise page all the indication also I have discussed, so we will not discuss any indication. This is your cabin pressure system page, and complete indication will come on that. Already this video is also available about all the indication, normal, abnormal condition on my channel, so will not cover here. Just check my YouTube channel, you will find out all the ECOM control page about the indication. Here I just open, you can see, just for example, this is your pressurization compartment. So here you will find out there is a safety valve, there is a two safety valve, but any one will open, this will open in amber color if it is open. So for two safety valve, just one indication is there, and there is a system 1 and system 2 means any one only will be visible, just like system 1 means CPC1 is controlling this all the pressurization system. After landing, changeover of computer, for the next cycle system 2 will take the command. So this will keep on changing. If there is a amber caution, means failure of one system 1 or CPC1, it will automatically switch to CPC2. In case of both will fail, then RPC will take care for depressurization after the landing. So this is all about that indication. Go to my YouTube channel for complete knowledge, in detail knowledge about all the ECOM control page. So if we talk about this is a very interesting chart and we'll cover all the indications. So if you see that cabin altitude is limited to 8,000 feet with a delta pressure 8.06 psi for aircraft altitude 39,000 feet. So up to 39,000 feet maximum cabin altitude it will be 8,000 feet, and if the cabin altitude increase, what will happen? Just for example, cabin altitude increase to 9550 feet, you will get master caution and you will get ICAM warning for that. If you are going further, pack sign warning will come on 11,300 feet, passenger sign will activate it, and in the outflow wall safety device close the wall when the cabin altitude reaches to 15,000 feet. So outflow wall will automatically close when the cabin altitude reaches to 15,000 feet. So under normal condition, landing field elevation selected in auto position, enabling the cabin pressure control computer to use the landing field elevation data from the FMGS flight management guidance system. That computer will give data to CPC about the landing elevation position. In all other case, landing elevation selector signal override the FMGC data semi-automatic operation, and there is a ditching push button which is to close the outflow wall in the case of ditching configuration. So this is your ditching push button. Here only this is talking about the outflow wall, but there is a lot of function. It will close all the avionics equipment ventilation wall and pack inlet outlet pack inlet wall, all the wall will close. And there is a video for this also, what are the purpose of ditching push button on my YouTube channel. So go through my video for in detail about this ditching push button. So this is all about aircraft altitude is 39,000 feet, and 319 will not discuss about this. To up to 39,000 feet Airbus can fly safely, and these all are the scenario whenever you get warning, whenever you get the pack sign. So if you go to the next video, if you talk about the cabin pressure controller. So cabin pressure, there are two interchangeable controller. I have told about CPC1, CPC2. By means of pin programming, each controller has automatic and manual part which are functionally and electrically independent to each other. So both will work independently, and if you go in more detail, one controller operate a system at a time according to the flight profile data and aircraft configuration. Second controller will be always in the active standby with automatic changeover after each flight in case of failure of active one. So in case of failure of active one, automatic it will change over, or each flight it will automatically change over. So it will not keep on flying on the one computer. Always one will go in the rest mode, other will take care of the command. So every flight one will change over. In case of failure, automatically will go to the backup mode. So CPC input, if you talk about the CPC inputs, what are the CPC input? You can see there is a lot of input are there. Flight management guidance system, you can see FMGC, it is taking data from the FMGC, you can see one, and it is going to CPC2 also. Then it is taking LGCIU data also, LGCIU also giving data to both computer. Then environment control system also will give data to this computer, and FWC flight warning system also will give data to this. So a lot of inputs are there. You just follow the charts. HDAC computer are there, flight warning computer are there, aids are there. So when manual mode is used, manual part of controller 1 operated only as a backup indication circuit processing output for that. So when manual mode is used, manual part of controller 1 operates only as a backup indication circuit process and output for the indication and monitoring. CPC1 manual part output for monitoring and indication are FWC and HDAC. CPC2 manual part is not used. So mostly CPC1 will use for the manual part of output for monitoring and indication of FWC and HDAC used. When manual mode is used, manual part of controller 1 operates only as a backup indication circuit process output for indicating and monitoring. CPC1 manual part output are monitoring and indicating our FWC and HDAC computer. CPC2 manual part is not used in the CPC2 computer. So if we talk about the outflow valve, this is your outflow valve. We will go in detail about the outflow valve also. In automatic mode, outflow valve is controlled by the operating controller, means computer CPC1 or CPC2. Outflow valve is a double flap motor driven type. You can see there is a double flap. If during walk around also you will see that. And automatic operation of outflow valve is by the two electronics motor 1 and motor 2. You can see there is a module 1, module 2, motor 1, motor 2, and electronic module 2 is controlled by the CPC2, and module 1 is controlled by CPC1. And if you go further, there is a two electronic actuator interface with the controller. Pressure switch, which only operates in automatic mode, is installed on the each electronic actuator. There is an actuator and there is a pressure switch on that. It closes the applicable outflow valve in case of cabin altitude is going above 15,000 feet. In a simple way, above 15,000 feet automatic pressurization function will take in place. And motor 3 is controlled from the cabin pressure panel by the manual vertical speed controller toggle switch. So there is a toggle switch. This is a manual vertical controller toggle switch. Motor 3 will take command of this through this only. So up and down means just open and close. That's why it is written up and down. Everything is automatically depend on the requirement. Captain can select the manual operation also. And if you talk about the mode selector push button, manual motor is used in case of failure of system 1, system 2. Then mode selector switch, you will get fault light also, and you can select man. You will see there is a man word. Once you selecting, then it will commanded through this toggle switch. Then if you talk about the safety valve presents the excessive positive and negative pressure in the fuselage are installed on the rear pressure bulkhead above the aircraft flotation line. So it is above the aircraft flotation line. Just check in the CBR or DR compartment rear pressure bulkhead, you can find out the safety valve. Or from the aft galley, if you follow the oil seat, oil row in front of oil row, you will find out that location of the panel about that safety valve. So if you talk about RPCU, this is your RPCU computer. This is also beautiful computer. RPCU interface with the CPC. You can see there is a lot of indication about this yellow line. This line we'll discuss in some other video. What are the purpose of why this color coding are there? Digital bus, airing bus. There is a lot of lines are there. DC bus, agency buses. So we'll discuss in separate video about this. So here we will discuss about RPCU interface with the CPC computers and taken over the control of the outflow valve automatically. This will take care of the outflow valve automatically if the outflow valve is not in fully open position when the aircraft is ground. So what I told in the starting of the video, when our aircraft is going to land, RPCU is the computer which will automatically open the outflow valve completely when the aircraft touches on the ground. This is to prevent the door violation opening in case of residual cabin pressure is there. So this is another backup computer, you can say. CPC1 will take the command, but RPCU will just support while landing. It will depressurize complete aircraft to prevent the residual pressure available on the cabin. And outflow valve, control of outflow valve by the RPCU is done through the motor 3 only. So RPCU, I told RPCU will take care of the motor 3. So there is a motor 3 is controlled from this toggle switch, and you have to activate mode selector. Then RPCU also, you can see there is a signal going from the RPCU. So this is good to know information. Is the motor 3 is a backup system for depressurization as well manual control of outflow valve. Whenever the following situation is detected, first situation is when the both landing gear are compressed or one landing gear is compressed and parking brake is set on. So this is your first condition. Both master switch are off, our aircraft speed is below 100 knots and outflow valve is not fully open. So this is another condition. And third condition is cabin pressurization system in the manual mode or both CPC or inoperative. Then also this will come into the picture. In this case, all the outflow valve is driven to fully open position by the RPCU condition. So there are total three conditions. First, just for example, landing gear must be compressed, or one parking brake light is on, or master lever switch is off, or air cut speed is below 100 knots, or cabin pressure system is in manual mode for the both CP or both CPC are inoperative. So in this case, outflow valve will fully open condition. So this is all about this. I hope you got knowledge about this, all the flap. This is your outflow valve. During walk around you can see this outflow valve, and this is your just for diagram, and I am suggesting this is your safety valve, how it will be looks. So we'll go in the next further in detail. If you'll go, what are the, there is a lot of things again. We'll discuss about this signals in later another separate video. So here you can see how the motor 1, motor 2, motor 3 are there. This is your cabin pressure controller, this is your air conditioning control panel, and this is your CPC CPC1, CPC2. And here you can see there is a one line, it is going from motor 3 to this will give indication on the cockpit. That's why CPC1 is that's why this CPC1 is no go, because this is act as a feedback sensor, additional pin programming for additional function, so that's why this is no go computer. And if you talk about what is the purpose of EIU, you can see this many will discuss one by one for better understanding. So if you discuss about EIU, engine interference unit, this will send the thrust lever angle associated with N2 signal to the both controller to initiate the pre-pressurization and pressurization sequence. So signals are thrust lever angle in takeoff position, maximum continuation or flex detent, third is N2 at or above idle, used for pre-pressurization and pressurization purpose. If you will talk about the landing gear, LGCIU landing gear controller interface unit, this will send that. What is the purpose of this? Simple language, you just keep in mind. This will only give the flight ground logic signal to the both controller to initiate pre-pressurization and pressurization and depressurization sequence. So this all three will taken care by this. So just for example, aircraft is on landing gear and aircraft speed is some whatever required speed, it will start going for pre-pressurization mode. Once it will go to 15,000 feet, it will go in complete automatic mode for pressurization, and after landing it will depressurization the sequence. So this is a function of ground flight logic. There is a lot of proximity switch. This is also we'll discuss in the separate video. How many sensors are there on the LGCI, means landing gear control, how many sensors are there on the landing gear. If we talk about the ADIRU 1, 2, 3, this is also giving data to all the both computer, and FMGC also giving data to giving data to this CPC1 and CPC2. So ADRU send the static pressure and barometric correction signal to the both controller pressure, and this signal can be static pressure, baro, ADRU validity used for all the sequence and priority selection. There is ADRU 1 and 2, 3 send the signal to controller 1, and ADRU 2, 1, 3 send the signal to the controller 2. Just keep in mind this is the sequence about that. If you talk about the FMGC, this is your flight management and guidance system. Manage and guide two system send the cruise flight level and landing field elevation data for the both controller. So this will give signal about on the account cruise flight level, cruise page will come into the picture, cruise flight level and landing airfield elevation used for pressurization profile. So this will take data from the FMGC. So if we talk about the motor, manual mode, already I told you there is a feedback position for motor 3 sent to the controller 1, and RPCU control the residual pressure in the cabin, take over the control of outflow and automatically by providing the power directly to the manual motor 3. So these all are about that. They used to use RS422 buses. You can see discrete signal from the active controller. We selected the corresponding motor and enable the signal while outflow valve positioning and monitoring signal are transmitted by RS422 bus. So it will be transferred to ECOM from RS22 bus. If cabin pressurization panel already you can see toggle switch, manual control, then field elevation automatically it will be in auto position depend on the requirement. It can go for the manual. Whenever you are going for manual operation, to identify the field elevation you should check the map or chart and just select that according to that requirement. And ditching already I have explained. So here if you go in more detail, let's go in more detail about that RPCU. So RPCU, residual pressure control unit, has the following interface with EIU, LGCIU, ADRU, parking brake, and this cabin pressure controller CFDIU for fault generation, motor 3. So motor 3 also it will give signal. So these many things are there. If you will talk about the EIU, we will discuss about the RPCU. How it is functioning for that, what are the interference are there. So EIU, engine interference unit, send the position of the related engine master switch is on and off to RPCU. If we talk about the LGCIU, landing gear interface control unit, this will send the signal to left LH and RH main landing gear is compressed or not. Third is ADIRS. So air.inertial reference unit send the air cut speed below or above the 100 knots for taking the condition of depressurization. Second is next is your cabin pressure controller 1 and 2 operative. RPCU has another interface. First is CPC1 signals if CPC1 is operative or inoperative. Second is outflow valve position of the potentiometer 3 is sent to the manual part of CPC1. So there is a manual part of CPC1, you can see here. It is not available in CPC2. And CPC1 detect if outflow valve is 100% open, then only it will give indication. And if you talk about the further, there is the input if RPCU needs to control the outflow valve to fully open position. These input are determined if the RPCU needs to control the outflow valve to complete open condition and open position. Therefore RPCU will send a direct signal to the motor 3 to open that outflow valve. So there is another interlink. RPCU sent a discrete signal. This is a discrete signal and signals to be CFDIU for fault information, okay or not okay, which lead to a class 3 fault indication into the class 3 failures. If we'll go in the further, and this I have covered, this also I have covered. Now CPC interfaces, we'll see what are the interfaces there. There is a flight warning computer. So what is the interface with the CPC? So we'll check it here. In case of excessive cabin altitude, active controller send a discrete signal to the flight warning computer for level 3 warning, and warning is generated if the cabin altitude exceeded 9550 feet. Then only CPC will give the warning to the FWC to generate the level 3 warning. So level 3 is a higher warning, and higher the level, you can see warning is high, simple. If you will talk about the maintenance point of view, class 1, class 2, class 3 failure, class 1 is the higher fault and you have to take immediately, and level 3 is a higher, this is for the captain. So level is for the captain and class is for the engineering team. If we talk about the SDAC computer, both controllers send the airing and discrete signal to the SDAC when the system is in automatic mode. Airing and discrete signal are used to monitor the monitor and warning indication if the manual mode. In manual mode, 3 analog signal are provided from the manual part of CPC1. So there is a 3 analog signal. This is basically in detail knowledge for the B2, but you can understand about that. In manual mode, there is a 3 analog signal are provided from the CPC1 only. That's why the CPC1 having lot of concept. Computer part number is same. Always just remember, wherever computer you are installing, there is a lot of pin programming additionally for the additional function. So computer you can swap anytime, but function of the CPC1 will be different than CPC2. And then CFDIU, both controllers send the byte data for the centralized fault display interface via the airing buses. This is your airing buses, and data is sent continuously or on request. So guys, with this I have completed about the pressurization system. If anything you want to ask, you just type in the comment box. Definitely will try to give answer. And if you really love this video, please don't forget to like, share, subscribe for getting more video on Airbus 320 family. And I will try to keep on updating about all the ATA chapter slowly. Just wait and watch. You'll get a lot of knowledge through my channel, and I am also trying my best to give you the best data for better understanding. So see you guys on the next vlog.